Next speaker will be Professor Yoshida from Japan, and he is talking about Doppler angiography with OCT. Professor Yoshida.
Thank you very much. I'm happy to be here, and I'm Akitoshi Yoshida, Asahikawa Medical University in Japan. I have been studying retinal blood flow for more than 30 years, okay? And at the beginning, I used to work with the Gilbert Fick Skepens and also George Benedict, MIT. Regarding the significance of measuring ocular blood flow is, right, for example, result of the laser Doppler velocimetry, we studied diabetic retinopathy, retinal vein occlusion, AMD, glaucoma, and others. However, laser Doppler velocimetry was not perfect. Retinal blood flow should be parabolic in this technique and needs patient good fixation ability. And rate of the successful measurement is not so high. So, we first to develop of Doppler OCT, DOCT flow meter in 2012. At that time, this is the instrument, based on the Topcon 3D OCT 2000. And it was not so easy to measure. This is one of my colleague, Dr. Tani. At that time, he was only be able to manipulate this instrument. So, if you look at the papers, previous Doppler OCT instruments have been reported by very scientific, very scientific doctors, as shown in this slide. But no clinical use Doppler OCT, DOCT instrument was available. If you think about advantage of a DOCT measurement, since we have a OCT, OCT can, of course, take a structure image, and also OCT can get the functional image, and from these two, we have a flow image. Now, talking about 2012, manual alignment was needed in this technique. This is the pupil, this is the center of the beam, and if you shine like this, and the angle between incident beam and vessel close to 90 degrees, no signal is going to be get. So in that time, appropriate condition was needed. Just a little bit, bend this beam and create something like 80 degrees by manual. Now, very recently, we developed fully automated Doppler OCT, Auto DOCT, 2016. This is the one. Everything is automatic. So I'm going to show you the with videotape how easy to get the retina absolute blood flow. This is the one. This is Topcon based. Everything is auto. All right? We decided to do the segmental blood flow instead of circular. And as you know, direction of the vessel, blood flow is different. That's why we can get these images. This is the precise description of our auto DOCT. And we have to do 4 things in order to get the absolute blood flow. First, 1, select scan location, auto alignment, Doppler angle estimation, and measurement. All right? This is the eye, and we have to do the manual this. And second, appropriate Doppler angle is automatically calculated. This is automatic. So we don't have to worry about this. It said 80. It's okay. Now, live flow imaging, we check. Then finally, push the button to get absolute retinal blood flow. It takes only 3 seconds. This technique shows both absolute retinal blood flow and structure, but not only this, we can get retinal blood velocity profiles. I will show you later. This is the absolute blood velocity value, multiple vessels at the same time. This is the blood velocity profile inside the vessel. And we used this technique to cat eye first. All right. DOCT shows better CBs compared with laser Doppler, which I invented, and Canon took the patent and made it. Now, to use the human eye, a little bit different because we have eye movement. All right. This is the CB of red blood cell, retinal blood flow. Look at this is a very, very good reproducibility. So, advantage, it non-invasively measures the difference in blood flow between healthy eyes and diseased eye because it's absolute measurement, not the relative, like a laser speckle. Okay, this is the glaucomatous eye with single hemifield damage. I'm not personally interested in glaucoma. I'm a retina, but you know, by looking, here is a NFLD, and this is the Humphrey field. Since I'm not familiar with the glaucoma, I always use like this. Around NFLD, we have a scotoma. Okay. Now I'm interested in this kind of thing. We measured this blood flow in the artery and this blood flow in the artery. So look at this, please. This one is blood flow is 1.92 microliter per minute. So this one is 7.12 microliter per minute. It means that the area of damaged field, retinal blood flow, is extremely significant decreased. So, which may cause another progression of the glaucomatous scotoma. So, we did 31 cases, and the paper is under preparation. Second, I want to do more. So I put the angiogram in this auto OCT. So I'd like to do everything. Blood flow and pulsatile curve and profile and angiogram, all in one. So this is the ultimate OCT for ocular circulation. We investigated retinal blood flow reaction during elevated IOP using auto DOCT and Doppler OCT angiography in cats. Okay, increased IOP. This is the picture of the Doppler OCT angiography, 10, 60, 70. I'm not satisfied with this. This is a all or none stuff. Abrupt change, okay? Should be not like this. Okay. This is the same experiment. IOP increased, auto Doppler OCT. This is the real blood flow measurement. Artery, vein decreased, gradual change. Should be like this. So, when I focused on the concentrate on the at IOP 60 millimeter mercury, around 50% reduction in blood flow measured by auto DOCT. On the other hand, at IOP 60, no remarkable change in OCT angiography. There's a big discrepancy, and we had a work on that to compare between two, and right now we are reached to the point that this could be more gradual change. Because of the patent, I'm sorry I cannot tell you today. In summary, OCT can be used for multi-analysis, including blood flow and anatomical change, and so on. This is another hint. Further study is needed to show the full potential of our prototype auto DOCT. Finally, I would like to say that in some country, new president said something like America first, but in terms of the making ophthalmology equipment, maybe Japan could be the first, and this company could be the first. Thank you very much.